Can you see what number is in this picture right here? If you can't, then perhaps you're red-green colorblind. But how did you get that trait? Well, that's what this video is all about. So sex-linked traits are traits that are found on the sex chromosomes. Now remember, we have 23 pairs of chromosomes. The 23rd pair, those are the sex chromosomes, the X and Y. Now as we head into this topic of sex-linked traits, I want to recognize that in our culture at large, there's a lot of differing ways to discuss gender and sex, and a lot of unhelpful stereotypes around gender. And so the purpose of this video is just to teach about the sex chromosomes and sex-linked traits. But if you ever wanted to talk about any of those other things, I would be happy to chat. So, with the sex chromosomes, XX chromosomes are for biologically female, and XY chromosomes, biologically male. Now, as you can see, this X chromosome here is a lot larger than the Y chromosome. And so because of that, the X chromosome has a lot more genes on it than the Y chromosome. So one of the genes that's on the X chromosome is this red-green color vision gene. And so this gene allows you to distinguish between red and green. And so if you have normal vision, you can see all these colors. This is what it would look like if you were red-green colorblind. So our two alleles for this gene, we're going to use R. So a big R would be for normal color vision, and a small r will be for red-green colorblind. Now remember, if you have the sex chromosomes XX, like here, you would have two copies of this gene. Let's draw it just right here for reference, right? But if you have the sex chromosomes XY, you're only going to have one copy of this gene. So let's think then about what all our possible genotypes could be. Now, with sex-linked traits, we write the genotypes a little differently, so pay attention to this. For this individual, we always start by writing the sex chromosomes, and then we add the alleles up here. So say they were homozygous dominant, it would look like this. So instead of just writing big R, I put those on the sex chromosomes to represent that this is a sex-linked trait. If this person was heterozygous, their genotype would look like this. And if this person was homozygous recessive, their genotype would look like this. Now, for this person, let's start with the sex chromosomes, X and Y, but we're only going to add in one allele. This gene is not on the Y chromosome, so we're not going to put any allele over here. So this person can just be dominant or recessive. And this is why sex-linked traits, sex-linked recessive traits, like red-green colorblindness, show up much more often in males. Because if they get one recessive allele, then they're going to have that trait. They don't have a chance to have a dominant allele that would hide that. Okay, so let's do a practice Punnett square. So here it says cross a heterozygous female with a colorblind male. So of course, we first want to write out their genotypes. So our female is going to be XX, and it tells us she's heterozygous. So remember, that means that her alleles are different. So one dominant, one recessive. Crossed with a colorblind male, so our male is XY, and he only has an allele on the X chromosome, and he's colorblind. So that means that it must be the recessive allele. From here, we do our Punnett square, just like normal. Oops. We take our parent genotypes and we split them up. Okay, next little r. So now this is the second parent, and Y. So remember, we always write the one with the dominant allele first, if there is a dominant allele. This one would be X little r, two recessive alleles, X big R, Y, X little r, Y. Okay, so you can also see that this is why they say you have a 50-50 chance of having a girl or boy, 50-50, which isn't quite true. There's other things that can affect that. But anyways, so in this case, this would be female who is heterozygous, so she would not be colorblind. This is a female that is colorblind, which is very rare because it's more rare for someone to get 2 of these recessive alleles than just 1. So this would be a colorblind male, and this would be a male with normal vision. So that is how to do sex-linked traits.